Good morning, hello, good afternoon, good evening. Welcome to another edition of TaiyangNews Webinars. My name is Michael Schmäler. I'm the Managing Director of TaiyangNews, and I will moderate today's webinar. What we're looking today is bifacial solar technology. We kind of termed it as this webinar as understanding bifacial's PV's true potential. So we really want to put the spotlight on performance modeling, field studies, innovations, and also the technical bankability of bifacial PV projects. As you probably all know, bifacial is pretty hot these days and is supposed to become really a standard very soon. I think there are a lot of projections, at least, forecasting this, and we just want to take a look today with our guests at what the challenges are that we're seeing in today's project. So we've invited three external speakers to presentations. The introduction will be given by my colleague Shravan Chunduri from TaiyangNews, who will give an overview on bifacial solar technology. We will soon be also coming out with another report on bifacial technology, and we'll just take a little glimpse on that. Then we have with us Roberto Morgioni from JinkoSolar, who will talk about design optimization for bifacial solar and really look into their experience as the world's largest module manufacturer, really also being a pioneer in this segment, sharing what their experience is. And then we have, we're really happy to have, they're really early in the day, Christy Line and Silvana Ayla-Pelez with us from NREL, PV Performance and Reliability Group, specialists in bifacial solar technology, and they will really share with us their research on modeling and what's the reality of bifacial PV products. So before we start, you are able to ask questions. Please use for that the control panel. I will collect the questions and then I will ask that after the presentations. We have 60 minutes. We strive to stay within this 60 minutes. So then I would like to start and hand over to Shravan, who will give an overview on bifacial solar technology. Shravan, the floor is yours.
Thank you, Michael. Hello. Are you able to see my screen?
Yes.
Okay, great. So, hello everyone.
We see at the moment, Shravan, we see your background, your Microsoft background, not the presentation.
Oh, okay, that's bad.
And please go into presentation mode also.
Yes, I will do that. Okay, so now is it fine?
No, we see still the the small pictures on the left. You have to go to slideshow.
I am already on slideshow.
Maybe.
Is it not?
No, I think then go to view maybe and change.
On slideshow, there's an option to select the monitor to be your primary or your outside, or just remove presenter view.
Shravan?
Yeah. Can you see that? I cannot do that.
Just open it.
I opened it.
It's inside of the PowerPoint option.
Go open the PowerPoint.
Yeah, I just opened it. Somehow it's not. Can you see now? It's in presentation mode.
But go to display settings maybe and
The slideshow tab inside of PowerPoint.
Okay.
Shravan, I can take over and show the presentation here. So just tell me
Oh,
to
okay.
switch to the next pages. Okay.
yeah,
Yes.
super. Thanks, man. Sorry.
Thanks. Okay. Okay. So hello everyone. I'm Shravan Chunduri, Technology Head at TaiyangNews. Welcome to my presentation. Today I'm going to give a brief introduction about bifacial technology. Next slide. So before I go into my presentation, I would like to take this opportunity to provide a brief introduction of our company. We are actually two companies and we have two platforms. TaiyangNews is an open platform. We publish reports on advanced cell technologies, and we also publish market surveys on various production equipment and process consumables. Actually, the differentiation with TaiyangNews is that it is an open platform. That means all the publications can be accessed for free. We also offer a paid service through our consulting arm, Mishko. Through Mishko, we provide services such as communication strategy development, technical research, and market intelligence. Slide 3. Next slide. So going into the subject, which is bifacial, TaiyangNews has published 2 editions of reports on bifacial technology, and we will publish our 3rd edition of the report on bifacial technology very soon. So actually, while our previous 2 reports mainly covered the cell side of the technology, the 3rd edition will mainly focus on module and system level. Next slide, please. So this slide is really for the beginners. So what is bifacial? So PV industry has been trying to utilize every inch of cell surface area for sunlight absorption. So different metallization approaches and back contact cell architectures are actually improvements in this direction. But bifacial is actually a new paradigm shift in a way that it activates the rear side of the PV devices for sunlight absorption, which is otherwise barren. Next slide. So as to the question of how to make bifacial, it actually requires a change at cell, module, and system level. At cell level, applying a rear grid similar to the front is more or less the key change. Then making the rear cover transparent is the major change at the module level. Bifacial technology offers a lot of potential for optimization at the system level, such as choosing sites with natural high albedo, increasing albedo artificially, then combining bifacial modules with trackers, and there are several other possibilities. So the most important thing here is all these changes are industrially feasible. Next slide. Going into the details of cell level, nearly all advanced cell technologies are bifacial. So, but this is not completely true for PERC, but it can be tweaked easily. It can be tweaked easily to make the PERC as a bifacial, and all other technologies beyond PERC are naturally bifacial. Here, what you see is I put them in their order of their bifaciality. So even technology like IBC, which completely moves the contacts onto the rear side, the contacts of both polarities onto the rear side, it's still entitled for a 75% bifaciality. Then passivated contacts, which is right now a very hot topic in the industry, it also has a bifaciality of 80%. So the reason for that is passivated contacts requires a polysilicon layer on the rear side. There is some this doped polysilicon layer also causes some undesired absorption. Because of that, the bifaciality is bit less, which is 80%. Then NPERC technology, which uses silver metallization on the both sides, it has a high bifaciality, like 80 to 85%, and heterojunction is currently the ultimate technology which offers kind of very high bifaciality of 90 to 95%. So next slide. As mentioned earlier, making the rear cover transparent is the main change required at a module level for the bifacial. So glass has been a natural choice here, because glass configuration has been known to push the warranted power warranty lifetime for 25 to 30 years. However, the first products with transparent backsheet are now available in the market from multiple suppliers. So Jinko, Jollywood, and there are also few other companies that are coming forward with the products that are using transparent backsheet. The speciality of the Swan series from Jinko is that they are also offered with 30 years warranty, similar to the glass modules. So less weight is the major benefit of the transparent backsheet at the module level, and at the system level. And processing front, employing a transparent backsheet enables to keep the module processing more or less the same. Then at module level, there are also few other changes that are required, changing the junction box design in order to avoid shading, and opting for alternate encapsulation material, especially shifting to polyolefins when using glass configuration, or other changes bifacial technology required at module. Then there are also a few other changes. So there is also a question on framed or frameless, but most of the bifacial modules are sold with frames as of now. Then other advanced module technologies such as half cells, multi-bus bar actually help in maximizing the benefit from the bifacial technology. As actually this is also happening, as you can see in the coming slides. Next slide. So actually this slide shows our listing of bifacial products in our last year's report. We cannot claim that we have every module on our list, but we really try to get the module data from most of the leading suppliers. So we were able to identify around 36 commercially available products. Majority of them are mainly bifacial modules, and few are combined with other advanced module technologies such as half cell and multi-bus bar. Next slide. So now you in this slide you can see that more and more companies which are offering only bifacial modules are getting very less, and bifacial is increasingly combined with other technologies such as multi-bus bar. Here you can see here is a multi-bus bar and bifacial, and only bifacial modules. And next slide. Here also you see that bifacial is now increasingly combined with other technologies. So bifacial plus half cell, then bifacial half cells and multi-bus bar modules. And there are also a lot of configurations available, right from 150 cells, even 156 cells. For example, Jinko has recently launched a Tiger series module, which is also a bifacial with 455 watt front side power. And then of course the other details are not yet available. So this is it's a tiling ribbon technology, but still they are combining with bifacial. So what we see here at the module level is more and more bifacial modules are combined with other advanced module technologies. Next slide. So at the bifacial at the system level, there are different things that are going to play. So installation site albedo is a major contributing factor for the bifaciality. And so bifaciality is nothing but the ratio of the power from the rear side to the front side at STC conditions. And actually there are sites with natural albedo. So for example, here on the slide, on the graph on the right side in the top, you can see different types of ground has a different albedo. For example, water has 8, and really a fresh snow can have a high albedo as much as up to 95%. And depending on this albedo, the bifacial gain of the modules also varies. So for in the lower graph, you can see soil and grass has a bifacial gain of 5.5%. And the snow, which has up to 70% of albedo gain, which has 16.2% bifacial gain. And now you can also increase the albedo artificially by using white coatings or white membranes or white paints. So by this, you can also get a bifaciality gain of up to 26.9%. So at system level, bifacial really offers a lot of opportunities to improve the yield, the energy generation yield. Next slide. So bifacial is really a very hot topic, and now it is also evolved to be very mature, but there are still several questions. So is the technology still bankable? So what is the status of the simulation, which is very important for estimating the bifacial gain at the inception of the project? Then how bifacial devices are tested, and what is the market share of bifacial technology, how fast it is growing, and how to exactly specify a sales metric for the bifacial modules. Actually, what are the challenges bifacial technology is facing, and how are the systems are performing already in the field? So these are questions, and some of these questions will be answered in the next presentations, and our third edition on bifacial solar module technology will also try to answer some of these questions. Thank you very much for your attention.
Thanks, Shravan, for this nice introduction, and yeah, also thanks for already asking some questions that we hope to be answered by the coming presenters. So our next presenter is Roberto from JinkoSolar, and as Shravan already mentioned, Jinko recently introduced a module with almost record-breaking power rating, and this solar module is also bifacial, and Roberto will provide us some background on their experience and how to really optimally design a bifacial solar system to really tap the full potential of such modules. Roberto, the floor is yours.
Yeah, sure, Michael. Thank you for the nice introduction. It will be my pleasure today speaking about bifacial, which is a new technology I mean, from massive production, and it's very interesting to speak also about all the design aspect of this new product.
Roberto, quick intro and try. Yeah, yes, please. And
yes,
go to,
yes. 1 second, and I go. You should be.
Thanks.
Can you see?
Yes.
Now, yeah, perfect. Okay, today from Jinko side, I will introduce quickly the company, just small numbers to show you where we stand at right now. We will give a look to our portfolio in order to show our products, bifacial products, and then we will move immediately to speak in details about the product itself, the technology, and how to better and to understand the general and details concept in terms of design for bifacial module. And let's start with Jinko. Jinko right now worldwide is #1 company in terms of shipment. We delivered more than 40 gigawatt worldwide, and we have a market share around 13%. I will say that I am proud of to say that we are also first in position when it comes to bankability. And it's very important, this number, because it really reflects the quality and the trustability of company and products. And that's our, philosophy. In terms of portfolio, right now we have, I will say, 3 high efficiency products. We can divide in 3, let's say, names, which are Cheetah products, Swan products, and Tiger, which is the new technology, the tingling technology already introduced before by Shravan. And how bifacial is penetrating the market? It's a nice question, and the answer is that right now the market is 3-4%, but we see that the interest is very high, and the forecast given by Bloomberg are impressive. 2025 market will be 40-50%, which is high penetration in the market about bifacial. From Jinko side, right now we have 2 main bifacial products. One is the Swan, which has 400 watt peak of only the front, and efficiency is 90.54%. Also, we have the Tiger one, which will be 455 watt peak, the front only again, which will have 9 bus bars and efficiency higher than 20%, and the linear warranty will be 30. In terms of product, in terms of Swan product, we're proud to say that we won the Solar Award in 2019. Why? Because the product is very innovative, meaning that the bifacial product itself that we promote is not using anymore the glass, but it's using the transparent backsheet, which is a new technology, and we collaborate with DuPont for this, and it's a completely different approach. And why? Well, first of all, the linear performance warranty will be basically the same as per glass, meaning we provide 30 years linear power warranty. And can you just confirm that you are that you see exactly the presentation in a large scale, or?
You do actually see always the following slide. But we see also on the left the current one.
Okay, just 1 second. I try to. Should be better right now, correct?
Now it's perfect.
Okay, so fine. I was speaking about the warranty, which will be basically, I mean, the same as per glass, and also you see the linear degradation will be 2.5% for the first year, and then 0.55% of degradation every year from year second to the third. Now we move to a very interesting concept, always related to the bifacial warranty. Why? Because finally we have defined the BSDC conditions, meaning we have a reference. Right now we can also define, I mean, the concept of bifacial standard test condition, which has been fixed for front irradiance 1000 watt meter square, as always, like in standard test conditions, and the rear irradiance will be 135 watt meter square. By using, considering the model with 1 meter height and this irradiance of the backsheet, we can have now a benchmark, a reference, to just to classify if the product is producing properly accordingly the datasheet and the nominal electrical output, or if it is underperforming or even overperforming, depending on the situation. But I mean, right now we have a current solution for P-type and N-type is still pending from the standards, is the test mechanism and the nameplate format undefined. But I mean, this process is going to be disclosed very soon. By comparing the monofacial and bifacial, it's immediately clear how bifacial will have a big impact in terms of business plans, in terms of LCOE, IRR, in terms of investment. It really, I mean, show this graphic. It's clear that bifacial will start sooner in the morning and will finish later in the evening to produce, and the contribute of energy will be higher daily. And it's very important. It shows immediately the behavior of the bifacial, because by using the same land, the same surface, we will increase the energy yield. And this is very open-eyeing, because I mean, from Jinko side, we strongly believe in bifacial, and that is why we developed a new product with the transparent backsheet in order to make these products fitting with the standard structures, avoiding using glass models, which has 7 kilograms more in weight, which is a huge difference if we are going to install the panels in a rooftop and even in large scale plants. And the transparent backsheet structure is the following. We have, of course, we are using the DuPont technology, which uses tedral material. And the key feature of this backsheet are the high transmission, the excellent anti-UV capacity, along using life. That's why we have 30 warranty linear performance either. And it's easy to clean, and I will show you later why. With this transparent backsheet, we can achieve a very high level in terms of LCOE, because we are going to increase the energy yield, but only slightly increasing the BOS costs. And the key points to differentiate the transparent backsheet and the dual glass is for sure the weight, which is lighter, 7 kilograms less. The installation is standardized as the usual systems. The BOS cost, then it's cheaper than glass. We will use the same standard equipment. The energy gain is equal and the warranty is the same. Those are the key points for the transparent backsheet technology applied to the bifacial cell technology. And other than that, I have to tell you that we have different technology in terms of transparent backsheet, we already developed a new one, which is slightly different. In order to increase the reflection inside, we have even the white mesh backsheet, meaning that this transparent backsheet will be transparent on the back side, but white in the front side. This white side will enhance the front side power generation around 5 feet peak more, 1 class more, just using the mesh layer. This is an important improvement. We will introduce this technology starting 2020. And this is how the market is also to show how the market is moving fast in terms of bifacial technology. Moving now to design concepts. It's clear from our side, based on our test facilities in Haining, China. We started to run some tests in January 2018. Still, we are collecting all the results. And thanks to that, we can clearly define that, of course, the higher, the better. And the more we get in height, the more we get in energy gain. On the left, we can see the graph, and of course, we have to always find the middle point, because increasing the height or the fixed racks will also increase the BOS costs. That's why we have to find the middle point. We always suggest for fixed installation at least 1 meter, 1.2 meters, in order to be in the we'll say that the middle point and the best point, in order to not increase too much the cost, but get the best result in terms of energy yield. And we go also for 1.5 meters for trackers. That's according to our results in our test facilities. And in terms of ground coverage ratio, also the results are impressive, because if we compare the energy generation and the GSR, I mean, it's clear how bifacial gain it's impressive. By reducing the GSR, we can increase the bifacial gain from 7.85% to 10.24%. One question that we get always from the designers and also from the investor is how the shading is influencing the energy yield. That's why today I would like to show the following two slides which compare the temperature in time when we consider a 0.2 on the left in the model, and we compare the two temperature on the frame and on the frameless. So what's the difference between a frame model and frameless? The final result is that the influence of the frame shading is negligible. Why? Because in the graph here, you can see how the difference in terms of temperature of the model it's really small. It's I mean, we can consider it almost zero, and that's very important for the designer when they are going to design the structure of the model, because now it's a difficult topic on the market is to optimize the structure on the back in order to increase the irradiance coming from the albedo, from the reflection of the environment around. And if we move comparing shading and temperature of the 2 points, 0.2 and 0.1, we see that transparent bifacial with junction box temperature is higher than ceramic grid bifacial. And in position 1, the ceramic grid bifacial temperature of shading cell are consistent with the temperature of bifacial. That's the temperature curve over time. Now we move to the next concept, which is finally the final results in terms of energy gain. The energy gain with shading, according to our test, in this particular test where we put, let's say, a profile here with 50 millimeters wide and the distance of 50 millimeters to the model, it's 20.2% with shading, and it's 20.79 with no shading. So the presence of the shading is quite irrelevant. That is why, I mean, sometimes in our vision, it's better to, even if we shade a little bit, but we don't increase the cost of the structure, can be a key point in order to save BOS costs in the systems. That's our final result. And as also a very important comparison we did in our laboratory test is we compare the fixed tilt generation and the tracking generation. And here again, it's important how to see how relevant are the results. For instance, if we compare the fixed structure with monofacial, we can increase with a grass albedo installation height of 1.2 meter, we can increase 7% the energy yield. So benchmark, the benchmark is always the monofacial. Now if we move to the same condition but with tracker, monofacial, and we replace with bifacial, we can increase the energy output about 12%. This is very important numbers to understand the investment key numbers, the energy yield. And getting, let's say, more into the design details, we also studied the mismatch losses coming for the bifacial modules. Why? Because basically, as you can understand, there is a non-uniformity in terms of albedo, meaning the panel situated on the edge are getting more reflection level from the ground than the panel situated in the middle of the array. And according to our studies, we say that, I mean, when we increase the installation height again higher than 1 meter, the spatial non-uniformities decrease about 5%. So one of the most important key points in order to reduce this mismatch losses are to increase the installation height, or either you increase the MPPT level presence in the arrays in order to separate the different irradiance level of the modules from the back. So there are different points where you can play in order to optimize the design, but you always have to consider that there is a 4% difference in terms of bifacial gain between the middle of the array and the edge of the array, as it's shown on the right side of the slide. Another key point in terms of installation design is the DC-AC ratio and, of course, the inverter design. Obviously, depending on the location, every designer used to, let's say, apply a different DC-AC ratio. With bifacial, you must know that the current can increase about 5, about 10, about 15, even about 20% some moments. This is very important in order to optimize the inverter, let's say, output. On the right side, you can see the output of the PVC simulation, because it's very important to consider the overcurrent coming from the bifacial when you are going to simulate the inverter output. So the point is we have to avoid the clipping losses from the inverter. And according to the albedo, according to the DC-AC ratio, we can also define the clipping losses and the bifacial gain. So the point here is when you are going to select the inverter, you usually have to properly check when this inverter is going to cut the maximum current and the maximum power in order to avoid extra losses, considering also the bifacial increment. And from the O&M, well, it's clear that from the O&M point, soiling and cleaning, we have tried and made several tests, specifically for the Tedlar material and for the transparent backsheet. And when we compare glass with transparent backsheet, we had much better result with transparent backsheet. First of all, because it has a hydrophobic property and have an excellent anti-staining features. And, we ran some tests in Chile, and it's important to say when customer asking, but what is the difference between the level of dirty in the front and the back? In the field test result in China, it is the soiling rate of the rear side is only 11% compared to the front side, meaning that the frequency of bifacial cleaning is much lower than the front side. This is very important to notice. Of course, there are some changes depending on the environment, depending on the location, but still the frequency is much lower than the front in terms of cleaning. Next slide, I would like to show then a business case study because it's very important to understand how the LCOE and why the investors are really attracted by the bifacial technology. If we take now a 100 megawatt peak plant, which is actually becoming a standard in terms of large scale plants, which is very big, but now it's very standard. And we take CAPEX and the OPEX, and of course, we get also annual irradiance. And then we have energy yield for 25 years. If in this business study, we compare the monofacial or 400 watt peak models with the Swan bifacial, what we can notice? First of all, in this specific case, according to the simulation, the energy yield is higher than 10%. Meaning, even if we increase the TOTEX, so the total cost of the investments from 72 million to 75, the LCOE will be better because basically the energy yield will be higher. So by using OS1, we can definitely reduce the LCOE if we compare with cheetah monofacial models. And an additional benefit, which is very important, is also that the bifacial Swan has a lifetime of 30 years, not anymore for 25. So also in terms of bankability, the PV park increases from 25 to 30 years productions under warranty performances. And getting more in details in a real plants in Spain that we have been working recently, I've run specifically the LCOE calculation for these plants, and I mean the key point again is that using the same land, using the same structure, just increasing slightly the BOS cost in the formula of LCOE, the energy level will be increased by 6%, 8%, 10%, depends on the location. In this case was 6%, But still, even calculating for 25 years in order to compare apples with apples, the LCOE has been reduced about 80% for this specific case, meaning plus 10% of IRR. That is why, I mean, those numbers speaks for the technology itself. That is why I see in a long-term bifacial taking more and more as one of the most important technology in the PV market. And as a final slide, I would like to show you some case studies that we have in Nijning. This one is with a white paint fixed installation with a tilt of 30 degrees, installation height 1.2 meters, and the ground type is white paint. In this period, we have calculated the irradiance and the output difference from monofacial and bifacial, and the swan bifacial reached an average of 16% more. Of course, this was a specific case where we on purpose painted the background. But for sure, it's an impressive result in order to have 16% of energy more. Going to a more realistic case where we have, again, in a tilt of 30 degrees, and but this time the ground type is grass and soil, which is a mix, quite standard, I would say, also in Europe. The gain of bifacial modules is 9% compared to monofacial modules. So if I mean, if there is any question still about the capability and about the possibility of this technology, for sure all the tests that we are running are, let's say, showing a very impressive results in terms of energy gain. And well, from my side, I think I took a little bit of more the time I have. From my side, I mean, that's pretty much all.
Thanks, Roberto. That was great. It was a little bit long, but it was very, very comprehensive and very informative. Thanks a lot. So with the final presentation, we come to our guests from NREL. Chris and Silvana will now put emphasis on modeling versus reality. And yeah, we're looking forward to your presentation. Please go ahead.
Okay, thank you all. Thank you, Shrevan, for the great introduction, and Roberto for the details on the bifacial technology. My name is Chris Line.
And I am Silvana Ayala.
And we're from the National Renewable Energy Lab in the PV Performance and Reliability Group. We're going to talk about practical consideration and details on our field performance. Go ahead and go to the next slide. So the previous speakers have really covered this in detail, so we'll just bring up the point that different bifacial cell technologies provide different bifaciality coefficient. This is the ratio of rear to front side performance under standard test conditions. These values are around 70% for PERC technologies, and up to 90% and higher for silicon heterojunction. These are the two technologies that we have deployed in our test field. So those are the two kind of numbers that we'll be discussing around for this talk. So, yep, next slide. Obviously, for a bifacial system, the main difference when you're talking about performance modeling is the additional rear irradiance contribution. So we have a figure of merit called the total bifacial irradiance, which considers two factors. You start with the front side plane of array irradiance. You then add in the rear contribution. As we mentioned earlier, the bifaciality coefficient of bifacial modules means that not all of this rear irradiance contribution is considered on the same level as front side irradiance. So when considering the total bifacial irradiance, you need to multiply this rear irradiance measured by a bifaciality coefficient of your module. This is because you're not making as much use of the rear irradiance as you are of the front side irradiance. But for most performance simulation tools, if you substitute this total irradiance for a front side POA irradiance, it does quite a good job of estimating your overall production. Next slide. So as mentioned previously, the ground albedo of your particular site has a large influence on the amount of bifacial gain you can expect from your PV system. And this can depend seasonally based on snow cover for your site. It can also depend on the ground cover at your location. So it's important to get a good, accurate estimate of your surface albedo to get appropriate field performance estimations. And so the ground measured albedo is kind of hard to come by. We do have a web link here for some measured sites around the US. And this can be a way to get accurate measurements, but it's probably better to do a field prospecting site at your own system to get a good estimate. The link is here, and if you have data to share, we'd love to include you in this study. Go ahead and go to the next slide. Another appropriate way to collect estimated ground albedo is from satellite measurements. Here we have a comparison of ground-based sensors versus satellite-based measurements. We do tend to see better agreement when there is not snow on the ground. The snow can be overestimated from the satellite resource. Fresh snow can have a very high albedo, but it tends to melt quickly, and so you get a lower effective albedo once the snow has been on the ground for a while. So for a snowy site on the left-hand side, we get a lower agreement in the winter time, but in non-snowy environments, such as in the desert here, you can get fairly good agreement between satellite-based and ground-based measurements. And these satellite-based albedo measurements can be collected from, for instance, NASA or the US NSRDB database has these satellite-based albedo measurements available. So just let us know. You can also follow this web link for more details from the bifacial PV workshop. Go ahead and go to the next slide. So when taking ground-based measurements, there are a few important considerations. The idea here is to have a representative ground cover that you're taking your albedo measurements over. You also want to avoid nearby shading. So the idea here is to collect a unshaded and representative view of the ground. Another consideration is that once you commence construction, the surface is going to not be the same as when you took the undisturbed ground measurements. So it may also make sense to look at the what will happen once you begin construction if you turn up the dirt, if the albedo will remain the same as when you took the initial measurements. But this is a useful measurement for field prospecting and for developing performance models and identifying the expected performance of your bifacial system. Go ahead and go to the next slide. However, once you have your field site up and running, it's also useful to be measuring the actual rear collected irradiance. And this gets back to our measurement of the total irradiance. So this is your measured G rear value. And this is because in a lot of cases, you'll have contract deliverables. For instance, if you have performance guarantees or initial capacity test measurements, this will have to be based on your incident irradiance on your system. So this will be a negotiation between the developer and the contractor that's putting the system together. But in a lot of cases, we recommend that these numbers be based on the total bifacial irradiance. For instance, otherwise the performance of a monofacial system is only dependent on the front side irradiance, but a bifacial system will have a performance dependence on this total irradiance. When deploying these sensors, it makes sense to have more than one sensor throughout the field because you're going to have albedo variations throughout your site. You'll also have spatial variations along the length of your modules. So you may not be getting the same rear side irradiance at the tip of a tracker row at the very edge of a module as you will closer to the center line where this torque tube is. You can imagine the shading effect and the albedo variation is going to give you a distribution across the module here. So it makes sense to take multiple measurements, both different locations throughout the site and along the chord of the module here. Go ahead and go to the next slide. So another important consideration in bifacial system performance is that a single module in a large field of reflected surface will give you a much higher rear irradiance than if you have a number of adjacent modules or rows in front and behind that are also casting shadows. So this is an important point because you can have a 50% reduction in the rear irradiance in a middle row of a middle module than you would a single module floating in the middle of a unshaded. So be careful when you're comparing field performance numbers. If the test results come from a small test field, you may not have representative performance to what you would get in a large scale system. So next slide, please. So this is a view of our field test site. This is a 10 tracker row bifacial system. We have a mix of monofacial and bifacial modules with both PERC and heterojunction technologies. In this case, we're collecting string level DC measurements, and we have, in some cases, the same PERC cell technology, both in a monofacial and a bifacial module package. So we can have a direct side-by-side comparison of the bifacial technology relative to its monofacial peer. And so if you go to the next slide here. Thank you. So we're going to be talking here about the bifacial energy gain of our system. So first we normalize the string performance based on the nameplate, the measured IV curve nameplate of the string. So we're avoiding comparing apples to oranges by normalizing by the power rating of the string. And you'll see here on a single sunny day and a cloudy day that there's visible performance gain of the bifacial string. This is similar to what Roberto showed. And if you go to the next slide here, the interesting thing though is that we actually get a higher performance gain on the cloudy day. This is also similar to what Roberto was saying, that early in the morning and under low light conditions, you actually get a boost in the bifacial gain under low light conditions. This is because you have the diffuse irradiance that is captured effectively on the bifacial system. And so this actually gives you a little bit of an advantage, particularly under high DC to AC ratio clipping. You get, or in diffuse climates, you may get a little bit of a gain from the bifacial system under these low irradiance conditions. This also means that it's important not just to look at initial conditions under sunny conditions, but to look at cumulative performance under all weather conditions for your site. Go to the next slide. So this is a rolled up cumulative energy gain for our systems under 6 months that we've had the system under performance. So here we have a PERC performance in yellow. This is an average of 2 different rows of PERC bifacial technology compared to the monofacial reference. This is normalized by the STC nameplate performance. We also show the silicon heterojunction row as a comparison. So in the first several months in the summertime, we get around a 6.5% bifacial gain for the PERC tracked systems, and we get closer to 8.5 or 9% energy gain for the silicon heterojunction. Go to the next slide. In the winter months, though, we get lower temperatures. So we'll see ambient temperatures drop from 25 degrees C down to single digits. We also obtained snow in October and November. So this increases the bifacial energy gain because of the higher albedo of the site. It also made the performance difference between the PERC and the heterojunction tighter. This is because the silicon heterojunction has a better temperature coefficient. But this advantage is less apparent in the colder winter months. Go to the next slide.
Okay. So now that we have our field results, we are attempting to model it on the available tools to predict the performance. And the two that we're going to be talking about today are some of the most common due diligence softwares, PVSys and SAM. And what powers both of these simulation tools is a view factor model, which is a geometrical analysis of the rear radiance that will reach the rear of the modules. And this is based on geometry, and it's very fast and very simple. And what we can see with both of the softwares between here seeing some days modeling the front and the rear radiance is that it's really closest follows what we expect, but it is under predicting on the rear irradiance. So we see that commonly on the view factor models. The prediction between both softwares is close to each other, but it is under predicting compared to the measured values in red. So again, if we look at the front irradiance, the model versus the measured for our data, it follows closely. It's a really good fit. But if we plot the measure versus the model, that rear radiance is under predicting, and so that tells us that the softwares are doing a conservative estimate of the expected irradiance input. The other thing that we can notice here on the data between SAM and PVSys, so there is a little bit of a wider spread on PVSys that actually seems to fit better into that model versus measured. But where this data points come from is from how the albedo is being taken in the softwares. PVSys is using a monthly albedo value that we provide. So we average all our albedos, we are measuring it on site. And on SAM, we are giving those measurements hourly. So every hour or every time point that we are introducing into SAM has the albedo for that specific moment. So we had a tighter distribution on SAM. So when we provide SAM with that monthly value instead, we see that same effect. And doing a first order modeling on SAM and PVSys of one of our PERC rows. So first order, there's a lot of more bells and whistles that we can fine tune to get this to match better to our field data on red. But what we can see is that SAM and PVSys are pretty close. And we also see that trend that we were seeing on the field data of increasing on October and November, of having a better performance in the bifacial module due to the snow, increased albedo, and the lower temperatures. So we do see that. Chris?
Yep. So pull up the next slide. So this highlights the importance of actually measuring the rear irradiance. So because the models are conservative, if you weren't measuring the rear side irradiance, you might not understand why your field performance is better than expected. But the G total gain, this is just the additional irradiance available on the backside. So this kind of gives you your entitlement of how much bifacial gain you'd be entitled to. This actually matches quite closely to what we're measuring on a power basis. So it's important to be tracking your field performance with a expected rear irradiance, measured rear irradiance, which lets you know sort of the maximum amount of expected rear production gain. Next slide. So because the view factor models can be somewhat conservative, we also have available more accurate performance models. This is a free open source software toolkit called Bifacial Radiance. This uses ray tracing to give higher accuracy, particularly for smaller systems. So we welcome you to look into some of our online webinars and training for Bifacial Radiance. And perhaps get used to some of these ray tracing simulations. And final slide here. So I'd like to close with a little bit of detail on system design. Roberto did an excellent job of covering this, but I'd also like to highlight a very good presentation by Itai Suez from Silfab. So this is available online from the Bifacial PV workshop. He ran some system optimization with the question of what's the most economic use of these bifacial modules? Do you directly swap in a bifacial module for a monofacial module in a traditional system design? How do you identify changes in the ground coverage ratio and the DC to AC ratio? Your particulars may be different. This system economics depends on your project finance considerations and the cost of your materials. But for this simulation, the actual advantage or the optimum was instead of looking at a one-for-one swap and keeping the number of modules consistent, you'd actually try to keep the energy yield consistent. Therefore, you would have a slightly greater row spacing, so reduce the ground coverage ratio. You would also slightly reduce the DC-AC ratio based on your bifacial gain, and you would try to keep your energy yield somewhat constant. So you would target the same overall energy yield, use fewer modules, and slightly greater ground spacing to meet the same energy yield. This was the most economic use of the modules for these particular considerations. So I think with that, that's all we had. And we're going to, so in conclusion, yeah, bifacial PV is becoming mainstream. Performance modeling tools are available. They're somewhat conservative. So field tests are highly recommended. Doing on-site measurements of albedo is a good way to reduce your uncertainty in modeled performance. And we're working to improve the performance models and keep an eye out for our upcoming performance upcoming presentations in future workshops and webinars. Thank you.
Thanks, Chris. Thanks, Silvana. That was really great. I think I learned a lot, and probably everyone else as well. I have to admit, we have really tons of questions, but we're running out of time. So first of all, so what I suggest is actually that everyone takes the opportunity and really sends her questions to the presenters. They will be happy to answer it. What we will do is we are working now on our bifacial report. We will try to address what we as TaiyangNews learned here today also in the report, and within as part of this, we will also try to answer some of your questions. Yeah, and the presentation will be online to answer one of the questions that was asked several times in the next 24 hours on YouTube, and it will be also can be downloaded on our website. So I'm seeing that many people are leaving now because they probably have further meetings. So I would say thanks a lot to our presenters. Thanks for everyone staying with us here for this hour. Wish you a nice day or a nice evening. Thanks so much, and we look forward to have you for one of our next webinars. Thanks so much. Bye-bye.
Thank you, everyone. Bye-bye.